Okay, now I want to look at some problems where we actually test the claim about a population mean. This first problem right here is probably one of my favorite types of problems because it actually does the hypothesis test for you in the problem right there. So you don't really have to do a whole lot of work. But let's look at the problem. The display provided from the technology available results from data using smartphone carriers' data speeds at airports. So I guess they're looking at the phone speed when you're sitting around at the airport to test a claim that they are from a population of a mean having less than 4 megabytes per second. Okay. So I guess that you are wondering if you don't have good cell service or maybe somebody's claiming that you have crappy service when you're at a airport, like less than 4 megabytes per second. Right there. So that'd be something you might be investigating if you're trying to see, does like air traffic mess with the cell phone signal or something. But anyway, it says use significance level 0.05. So the null and alternative hypothesis, we're doing to test the claim that the mean is less than 4 megabytes per second. So my original would be mean less than 4.00, which means the opposite would be mean greater than or equal to 4 megabytes. Which means our null hypothesis would have to be mu equal 4 megabytes. That comes straight from the equal that's in the opposite claim right there. So the opposite claim is kind of your null hypothesis, which means the alternative hypothesis will actually be the original claim less than 4 megabytes per second. And there's your null and alternative. Something also about the technology screen, it might be interesting to look at, but up here, this is your alternative hypothesis. It shows at the very top, so you can always kind of verify that whenever you get the output screen of t-test or something like that. So just keep that in mind. And then it says, what's the p-value for the hypothesis test? We don't actually have to do any work on this because it's already given to us. So the p-value, it's actually just straight from the calculator display, 0.000764, which we wouldn't be able to do this problem anyway. It don't give us the actual data in the problem anymore. It just gives us that display. So we wouldn't actually be able to use t-test ourselves anyway. Okay. And then what's the initial conclusion? Reject or fail to reject? Well, since the p-value is smaller than the significance level is 0.05. So we have our p-value, we have our significance level, and we do see that this is less than, so less. So p is low, the null must go. So we are actually going to reject the null hypothesis. And to get your final conclusion, just make sure you can follow your flowchart when you're trying to word this out. We're going to go to our flowchart now on the previous pages and figure out which path we're going to pick, which path we're going to follow. So since we're back at our flowchart now, we're going to look and see, does the original claim contain condition of equality? Well, the original said, we have mean less than 4 megabytes per second. So no, the original claim actually did not have it did not have the equality, and then we reject. We actually ended up rejecting the null hypothesis. Now this is something I would keep in mind here for your homework. They're actually probably going to have something like this on the homework. Instead of the sample data support, you're probably going to see there is sufficient evidence to support the claim that, and then the rest of it would be, the mean comes from a population with, or the mean, is less than 4 megabytes per second. Okay, the mean, maybe you could say the mean of the cell phone data speeds at the airport is less than 4 megabytes per second. Okay, so we'll word it like that when we go back to our problem. And you can see I went to my problem here and filled out the final conclusion from the table. There's sufficient sample evidence to support the claim that and this is, I just kind of adjusted the end statement. Let me underline this. I adjusted this end statement to kind of make sense with what we're actually doing. So I didn't copy verbatim the phrasing in the problem, but this is basically what you're looking at. Smartphone data speeds at airports have mean less than 4 megabytes per second. Maybe I should put megabytes per second. So on that right there, basically what have you figured out? So, from whatever sample they collected, right, from whatever sample they used to do this test, we've seen that there is enough evidence to support that there is lower data speeds at airports for smartphones. It does look like you're slowed down at the airport. It may not appear to it because we have such fast phones, but the data suggests that it does seem like they're slowed down a bit, or slower than 4 megabytes per second. Okay, that will be our final conclusion right there. And it's hard to interpret those sometimes. Sometimes you have to reread the problems. I often, a lot of times, go back and try to look at, what exactly is it wanting me to look at. It does take a lot of time to develop this final conclusion and think through what did you just find. So it's not a quick thing at all. Okay. Now, this next problem right here says in a sample of 36 cans of regular Coke, we found that the average was 12.19 fluid ounces. So our average for our 36 cans, our sample average is 12.19 fluid ounces. Assume a population standard deviation of Coke can volumes is sigma equals 0.11 ounces. So that sigma right there, we know we're going to use z-test when we get to a problem because it has the population standard deviation. Okay, and then it says use 0.05 significance level to test the claim. So we know we're doing a hypothesis test. Thus, we will use the z-test for sure to test the claim that the cans of Coke have a mean volume of 12 ounces. Okay, so our original claim, the Coke volumes, the mean is equal to 12 ounces. Okay, which means my opposite will be not equal to. Mean is not equal to 12 ounces. Which actually, since that's equal and not equal right there, your null hypothesis will be equals 12, and your null, or your alternative hypothesis, will be not equal to 12 right there. So there's your null and alternative. And then when you go to the calculator, you're going to see the symbols for this in a second. But we're going to put our data in the calculator. You're going to see a mu0 for the null hypothesis. So just keep that in mind when you go to the calculator. And then, of course, when you go to the bottom line, you just want to pick the not equals. It'll be like on the calculator, it should say not equal mu0. So when you go to the calculator screen, you'll see something that looks like that. Okay, keep that in mind. It says which calculator function will you use to do this test? We are going to use z-test since we see the sigma thing in the problem. So use z-test since sigma is known. In real life problems, you're normally not going to know sigma, but this is a problem. This is just a practice problem to get you knowing like when do you use this one versus this one. Now we want to go enter our sample data in z-test. And let's go on the calculator. We have stat, go over to the test menu. Z-test is actually the very first calculator function under the test, so I want to hit that. And then up at the top where it says input, right there, I don't have the data of the 36 cans. Like I don't have the ounces in every 36 cans of Coke. So we don't need to use the data. Let's use the stats, the summary stats instead. And then we're going to go down to the mean. This right here is the null hypothesis value right here. So we're going to put in 12 for that. And then the sigma is 0.11 right there. Our sample mean, basically our mean of our 12 Coke or our 36 Cokes was 12. And then we did have 36 Cokes that we were using ourselves. Okay. And then we want to pick the not equal symbol at the very bottom, and then we want to calculate it. So our p-value is 3.708 e negative 25. So the p-value 3.708 e negative 25, which is a lot of zeros. Like, that'd be like 25 zeros, like 0 point, and then 24 more zeros after the decimal. So lots of zeros. I'm not even gonna be able to write all those zeros, but you get the idea. Like, it's a really small number. If you wrote it out, if you had to round it on MyLabs to, like, 4 decimal places, you would do like 0, 0, 0, 0 on MyLabs or something. Okay, so very, very tiny number. And then initial conclusion: do we reject or fail to reject? Since the p-value is 0, basically, essentially, and our significance level is 0.05, we are going to have the p-value be less than the significance. So definitely p is low. The null must go. So we reject. And then once you reject the null, you can actually now go to your flowchart and see what the final conclusion is. Like, what exactly is the statement about this initial claim that Cokes have a volume of 12 ounces that's printed on the Coke can. Okay, so go back to your flowchart now and see what the actual final claim will be. Right here it says, does the original claim contain equality? Yeah, it actually did, because we're testing if it's equal to, the original claim was equal to 12 ounces, so yes, we did have equal. Do we reject the null hypothesis? Yeah, the p was low, so the null went. So you're going to say there is sufficient evidence to warrant rejection of the claim that blah, 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 blah. Okay, and then you'll fill in the original claim right there. So we'll go do that below, and then I'll get back to you. Okay, so I basically put in my final conclusion straight from the flowchart. There's sufficient evidence to warrant rejection of the claim that the mean volume of Coke, and then I put in each can or whatever, is equal to 12 ounces. Or you can say, yeah, the mean volume for Coke cans is equal to 12 ounces right there. You have enough evidence to reject that idea. Now, this is a question like, okay, in F it says, like, do you think you're being cheated out of your Coke? Because you had enough evidence to say that the 12 ounces is actually not true. Like, so what is it? Well, let's now look at our data and think about that. Okay, so what I'm going to do is go back to my data up here, and if you look here, our 36 cans of Coke, we actually had more than 12 ounces. Not a whole lot more, but a little bit more. So maybe not cheated necessarily out of Coke. We did see that the mean is not equal to 12, but what probably is going to be the case? Well, it actually might be that the mean is larger than 12 ounces. Like, it looks like we're actually getting more than what we what it has on the can, more than we purchased or whatever. So maybe not cheated necessarily. I would say I would lean more toward, we're probably getting more than we, more bang for our buck, basically. Okay, so that's what you would put on F if you had to explain that out. Okay. Look at this next example right here, where we have listed below are the numbers of years it took people to get their bachelor's degree. And it says use a 0.01 significance level and the p-value to test that the mean time to get your bachelor's is more than 4 years. So we want to test, does it take longer nowadays than 4 years to actually earn your bachelor's degree? Which maybe that's something I'm wondering, because I remember whenever I did my bachelor's degree, I actually took an extra year because I changed majors and something. Yeah, does it take longer than 4 years normally? Well, let's use this data right here and test that claim. Okay, our null hypothesis and our alternative. My original claim, the average amount of time it takes is greater than 4 years, so mean is greater than 4, which means my opposite claim will be mean less than or equal to 4. So we can set up our null hypothesis, mean equal to 4. That comes straight from the opposite claim. that means the original claim will be my alternative. Mean greater than 4 years. Okay. Now on this one right here, it says which calculator function we use to conduct this test. It is a mean, so we know it's going to be Z or T, one of those two. But on this one right here, we don't have the sigma symbol in this problem right here like we did in the previous one. So we're actually going to use t-test on this one. So we use t-test since sigma unknown, which would usually be the case in real life when you do these anyway for any kind of research you might be doing in your psychology stats or business stats classes. You'll use T methods for doing hypothesis testing. And then it says enter the sample information in your calculator and get the p-value for your particular sample. So one thing about this right here is we don't actually have summary stats either, but we do have data that they actually give us. What I want to do here with this data is enter this into list 1. I will need that at some point right there, so feel free to pause the video and enter the data yourself. That's what I'm going to do in list 1. Okay, as you can see, I've entered my data into list 1 now. Now we want to go to t-test on the calculator. So hit stat, go over to the test menu, and then we want to do t-test. And for this one, we actually don't have the summary stats given to us at all, like the sample mean, sample standard deviation. We could count up how many people there are. But since we put our data in list 1, we actually go over input data. So on this one, we want to do input data. And then for our mean, our null hypothesis, we're testing the claim that it takes 4 years to get your bachelor's. And then my data is in list 1, so just leave list right there as L1. Frequency is 1, and then my my alternative hypothesis, we want that to be greater symbol. So greater, we want to pick the last option right there, and then go down to calculate. And on this one right here, we can see the p-value is 0.0026 roughly, and that will be your p-value. And then when we conduct to get our initial conclusion, we're going to compare that p-value right there to the significance level, which is, in this problem, it's 0.01. I think in the previous problems we had it all being 0.05, but 0.01 is pretty common to use too. So the p-value is 0.0026, and the significance level is 0.01. We obviously see that this is less than. So the p is low, the null must go. So we reject the null hypothesis. Okay. And then to write down our final conclusion, that's where you follow your flowchart to get to the statement. We'll go over there now to our flowchart. So on this problem right here on the flowchart, we have the original claim. Does it have equality? Well, we're trying to test a claim that greater than 4 years to graduate or to get your bachelor's. That was our original claim. So no, that didn't have equal sign. It was greater. So we're going to follow the no path down through here. Did we reject the null hypothesis? Yes, we did. So we're going to follow this. There is sufficient evidence to support the claim that the time it takes to get your bachelor's is larger than 4 years. Okay, based on our sample data. Okay, and then we'll fill that in below on our problem. Okay, I wrote down my final conclusion just from that flow chart, filling in, the end. There is sufficient sample evidence to support the claim that the average time it takes to get a bachelor's degree is greater than or longer than 4 years. Okay, so it does seem like it does take a little bit longer than 4 years now for people to get their bachelor's degree. I ain't no shame in that. Take as long as you need, honestly, is what I say. There's really no rush to get in the real world. Trust me on that. And then we're going to look at one more problem with the same kind of idea here. This one actually wants to do test stat method on the problem, but we're actually not going to do that. We're actually going to do p-value method So you can ignore that right there. But I just wanted to do one more example using some data right here. This one is a sample where they're testing a claim that the speed of travelers is less than the speed limit of 65. So maybe like people are thinking people are going super slow, during this time of the day. Like maybe they think traffic slowed down or whatever at 3:30 on a weekday. So they're like, oh, this traffic's going so freaking slow. Tired of waiting in this line. We have data here. We will enter this into list 1. I'm actually going to go ahead and do that on the side. So just have that ready for yourself. But we want to write down our null and alternative hypothesis for this test. So the original claim, I'm just going to do my original and my opposite. We're testing a claim that the speed limit is less than 65 miles per hour right there. So we want to do mean less than 65. Okay. My opposite, which it's going to be mean greater than or equal to 65. So our mu0 will be less than, or our mu0, sorry, will be equal to 65. That comes straight from the opposite claim. That means the original claim is going to shape my alternative, which will be less than 65. So there's setting up your null and your alternative hypothesis. And of course we are going to go to t-test on our calculator. We are going to use, for our input, we're going to use data, since we don't have the summary stats. Okay, and then you want to put in your list as L1. Your frequency is automatically set to 1. And then for your bottom line, I forget what that bottom line looks like, but you're going to pick the less than symbol. So for that bottom line, you want to pick less than symbol. Okay, so we want to put that information in and get our p-value from t-test, just like the last problem actually. Okay, as you can see here, I've entered in my information into t-test. For input, I picked data because I was given my data, and then my null hypothesis, I put in 65. Of course, I put my data into list 1, and then I picked for the bottom line, I picked the less than symbol, since that's what my alternative hypothesis was. And then I want to hit calculate, and we end up getting a p-value here of 0.0018, which is going to be less than the significance. If we want to compare that to the point, what do we have? 0.05 significance right there. So we want to say, yes, this is going to be reject. P is low, the null must go. So we're going to reject the null. And then we want to figure out from our flowchart, what do we follow to, figure out like what the final statement's going to be regarding, do we think people are going less than the speed limit? Do we think traffic's really super slow at 3:30, at that time period, like we think it is in our mind? So we're going to go to the flowchart now. And back at the flowchart, we have the original claim. Does it have equal? Well, it was less than 65 miles per hour, so no, it didn't have equal. And we did actually end up rejecting the original claim, rejecting the null hypothesis. So we're basically going to say there is sufficient evidence to support the claim that the speed is less than 65 miles per hour during that time of day. Okay. And basically what I did here was I have written down my final conclusion from my flowchart, a very well written statement. There's sufficient sample data to support the claim that the average speed is less than the posted speed, which is 65 miles per hour at 3:30. So it does look like people are going slower at that time of the day than the speed limit or whatnot. Okay. So and it could be because it's busier, since it's 3:30 p.m. People are getting off work or going home, whatever. So it's understandable that it's probably less than the speed limit. So yeah. But there you go. There's some great examples of hypothesis testing for the average or for the mean.